subtracting rational expressions. So this is going to be similar to our adding. Remember, where we have to have the same denominator. So if this was written as maybe 2, 6 minus 1, 6, since these have the same denominator, then we would just subtract that top, keeping the same base, and that would be 1, 6, right? 2 minus 1 is 1, okay? But same thing as when we were adding, if they were different bases, 2, 6 minus 1/3, that's not going to work out well. Let's just do the same. 2/5 minus 1/10. Since they have different bases, different denominators, and we need to make them to be the same. Again, since this is a 5 and that's a multiple of 10, I can multiply both the top and the bottom by 2. So that would be 4/10 minus 1/10. And then now I can do the same thing here. Keep that same denominator. 4 minus 1 is 3. And then if that could simplify, I would need to simplify that. So we're going to do the same thing, but with our rational expression. So we're going to have the same steps as adding. So we need to rewrite using a common denominator. And then we're going to combine our numerators or combine like terms. And then we are going to simplify. So the only thing that you need to make sure when you are combining your like terms is your signs. So let's look at this. 16, 16, we've got the same base. So we can say 9x plus 12 minus 7x minus 2 all over 16. So 9x minus 7x is 2x. 12 minus 2 is positive 10 over 16. We can keep simplifying this because each of these can be divisible by 2. So as an answer, you would take this divided by 2. That would leave me with x plus 5 over 8. You might need me to explain that a little bit further if you don't remember how to do that. All right, same denominator, so I'm going to take that top and subtract it. So we got 1 minus 16 x squared over 12x minus 3. I can factor both of these. 1 minus 4x, 1 plus 4x over 3, 4x minus 1. And then I can simplify this to coming out to be negative 1 minus 4a over 3. Basically, these eliminate. I'm not going to ask anything that complicated with doing with negatives like that. But what I want you to get out of this is that they are common bases, so I'm just subtracting that top numerator. Okay. We've got different bases, different denominators. So I need to make them the same. Since they both have x, I can just multiply by the numbers and get them to both be 6x because that would be common. So multiply this by 3, this by 3, this one by 2, this one by 2. So 3 times 15 is 45. 3 times 2x would give me 6x. 16 times 2 is 32. 3x times 2 is 6x. So now I've got a common base. So you don't always have to multiply by the exact thing. If I multiplied by 2x and 3x, then I'd have a bunch of x squareds. They'd still be the same base. but it'd just be a little bit more complicated. So I'm going to take 45 minus 32, 13 over 6x, and I cannot simplify that any further. All right, here. This one's a little bit complicated because I can factor this denominator into 5x squared because I can pull a 5 out of both of those. So now both of my denominators have an x minus 2 in them. So all I need to do is multiply this one by 5, and then they would be the same. So multiply by the top. So this one's going to stay the same, x squared plus 16. And I'm just going to multiply 4 times 5, so then that's minus 20. And that is over my 5x minus 2. Simplify this to x squared minus 4 over that. I can factor x squared minus 4. That's a perfect square factor, x plus 2 over 5, x minus 2. And now I can keep simplifying because now those cross out. So finally, x plus 2 over 5. All right, make sure again with your subtraction that you are getting them to be the same denominator. I think I threw a couple of challenging ones like number 4 at you, but nothing super complicated. Let me know when you have questions.